In the Arctic, and through much of the Canadian boreal, water that has been trapped as ice in the form of glaciers, permanent snowpack, and permafrost is in decline. And while we may not have perceived it as such, what is happening in the Arctic and in the North is exactly what is happening in much of the rest of Canada. In northern Canada, water in the form of ice, snow, permafrost is beginning to melt, and fresh water stored for thousands of years in lakes is beginning to evaporate. The water is not disappearing, however. There's as much water on Earth as there ever was, no more, no less. What is happening, though, is that warming is causing much of our water to move to a different place in the hydrosphere, where it may not be available for our use when we want it. Warming is also concentrating more water in the atmosphere, out of which it may suddenly reappear in volumes that we haven't experienced before and don't have the means to easily manage. Through the efforts of the Western Canadian Cryospheric Network, researchers now know that we may have lost as many as 300 glaciers in the Canadian Rockies between 1920 and 2005. And there's clear evidence that our losses appear to be accelerating. Dr. Gary Clark at the University of British Columbia is one of this country's most respected glaciologists. He has identified what's happening in glacial circumstances and projected the changes that have taken place over the last 40 years into the future. This is the type of changes that we can expect if those circumstances continue. So you begin to see that the ice that we had will be gone in many cases, and certain ice fields themselves will disappear. So what's happening to our glaciers suggests that the future climate of the Canadian West may be very different than it is presently. While glaciers may not be as important in terms of total water supply as they once were, what's happening to glaciers may be a warning of other far more significant threats. We know already that long before global warming has finished reducing the length and depth of our glaciers, it'll already be after our mountain snowpack. And that could have huge influence on Western water supply. And based on September averages, however, water levels in Lake Huron have declined by 115 centimeters between 1997 and 2012. These declines are far greater than water level declines in other Great Lakes. And while the dredging of the St. Clair River outlet plays a role, it's thought that these declines in water level are related in part to a decline in the amount of precipitation falling as snow as opposed to rain in winter in Lake Huron and upstream in Lake Superior. And there's also, interestingly enough, been a decline in the extent and period during which the lake is frozen in winter, and a trend to greater evaporation brought about by higher summer temperatures. Higher evaporation rates result in lower inflows into Lake Huron. So what we see from this is that the same warming that is causing glaciers and patterns of snow deposition to change in the west are also causing water left on the land after the last glaciation in the Great Lakes region to move to a different place in the hydrosphere. So a rough calculation of the decline in water levels in Lake Huron alone suggests that as much as 67 cubic kilometers of water may have disappeared from this part of the Great Lakes system since 1997. So that's a lot of water. So one might ask, well, where did that water go? Well, one of the places it's going is into the atmosphere, where it becomes available to fuel more frequent and intense extreme weather events, such as the one that in only 2 hours caused some $700 million worth of flood damage to water infrastructure, roads, and homes in Toronto in 2005, with similarly expensive events since. It's become very clear that rising temperatures and the increasing concentration of atmospheric water vapor are making what were once predictable natural events much more severe. Stationarity could make parts of the central Great Plains region uninhabitable and could, if persisting, alter and perhaps threaten bankruptcy to provinces that are flood-prone like Manitoba. So when you look at this, non-stationarity becomes a serious issue. And the problem is that we do not yet have an adequate replacement for stationarity statistics. And until we find a new way of substantiating appropriate action in the absence of stationarity, risks will be increasingly difficult to predict or to price, not just in Toronto or Windsor or in Winnipeg or in Vancouver, but everywhere. That the world has changed in terms of the increase in frequency and duration of extreme weather events has been recognized for some time by the insurance industry. Those living in places of recurring incidents of extreme weather events are often finding it more difficult and expensive to buy insurance if they can get it at all. More people, therefore, are relying on their governments to provide disaster relief. And while a single event may not be attributable to climate change, Superstorm Sandy demonstrated that even developed countries may not be able to afford to adequately compensate citizens for damages caused by recurrent extreme weather events. In November of last year, the Federal Emergency Management Agency in the United States announced that it would need a congressional bailout to cover its flood insurance obligations, as claims for Superstorm Sandy could be as much as 4 times greater than the program's capacity to compensate for insured losses. But it is the uninsured losses that drive people into bankruptcy and poverty. As we saw during the flooding that occurred in the Central Great Plains region in 2011, uninsured losses can be 8 to 10 times greater than those covered by insurance. I wish also to draw your attention to a major new report released last November by the National Academies of Science in the United States in combination with the intelligence community of the U.S. government. The report's called Climate and Social Stress: Implications for Security Analysis. In my estimation, developers and individual real estate agents will face increasing liability for ensuring that buyers have full knowledge of the fact that the property they are purchasing is within a floodplain or subject to repeated flooding as a result of municipal water infrastructure designed for an earlier but no longer existing hydroclimatic change. In effect, it may be possible that real estate professionals may have to become de facto climate advisors and arbitrators in some instances. And what a different role for real estate that might be. I don't have to tell anyone in this room that the changes in the hydrological cycle are undermining traditional approaches to managing urban water infrastructure. There is a crucial need to assess the cost of adapting versus the cost we should expect to bear if we don't. And the magnitude of the problem is enormous, and budgets to deal with this problem are limited. The difficulty in addressing adaptation challenges in many towns and cities has been compounded by our already substantial municipal water maintenance and infrastructure maintenance and replacement deficit. Presently, there's considerable public and political resistance to making more money available to deal with these matters. And in some cases, that resistance is deep and entrenched. So just when you think matters can't get worse, matters of equity are also beginning to rear their ugly head. On one hand is the huge cost and public relations nightmare of being forced by recurrent flooding to retrofit whole neighborhoods to higher standards. And on the other is the issue of class action suits that have been threatened or brought against municipalities by those whose properties suffer repeated flooding as a consequence of having to live with existing outmoded infrastructure design standards. The largest fear is that the cost of this ongoing damage may in time be substantial enough, in some places at least, to make it difficult to sustain prosperity as we know it today and still keep our cities, towns, and national transportation systems and other crucial infrastructure in functional repair. And unfortunately, until we know how much global warming will occur and what consequences to affect, appropriate infrastructure design standards will remain a moving target. And the first thing we have to do is realize that the loss of hydrologic stationarity is a societal game changer. Let me repeat that. The loss of hydrologic stationarity is a societal game changer. What has become clear is that it isn't just emission cuts that we need to achieve to restore climatic stability. Difficult as these cuts may be, they will not be enough. In order to adapt and to flourish in changing conditions, we need to set new ecological restoration goals as well. Now, all that said, I would submit to you that this is not the end of the world, and nor is this the time to panic and throw up your hands in helpless despair. This is not the time for paralyzed resignation. The world is not coming to the end. The sky is not falling. This is not a time for irrational desire either. This is a time for leadership. Leadership that people like you can provide. We know from international example the most effective way to adapt quickly to the growing number of negative consequences and costly feedbacks associated with rapid eco-hydroclimatic change is to manage our water more wisely.